The brain is a mystery, its secrets slowly being revealed. New research has taken the prevailing theory that a word's meaning is represented by a group of regions in the brain, the semantic system, a step further. The fine details of this network, spread across the outer layer of the brain, have been uncovered. A team from the University of California, Berkeley recently published the findings from their research study. The study states, the meaning of language is represented in regions of the cerebral cortex collectively known as the semantic system. However, little of the semantic system has been mapped comprehensively, and the semantic selectivity of most regions is unknown. Here we systematically map semantic selectivity across the cortex using voxel-wise modeling of functional MRI (fMRI) data collected while subjects listened to narrative stories. Volunteers, including the study's lead author Dr. Alex Huth, listened to more than 2 hours of radio stories while remaining motionless inside of a functional MRI scanner. While doing so, the team collected information on changes in the brain. In particular, they noted changes in blood flow and oxygenation, brain activity in areas of the cerebral cortex, the brain's outer tissue dealing with language and consciousness. They compared the results of the brain imaging to time-coded transcriptions of the radio stories. Using a computer algorithm that scored words according to their relationship in meaning, the results were converted into a thesaurus-like map where the words were arranged on the left and right hemispheres of the brain. The study states, we show that the semantic system is organized into intricate patterns that seem to be consistent across individuals. We then use a novel generative model to create a detailed semantic atlas. Our results suggest that most areas within the semantic system represent information about specific semantic domains, or groups of related concepts, and our atlas shows such domains are represented in each area. The results show that areas of the human brain represent language describing people and social relations rather than just abstract concepts. One example is the word top. It was represented in the area of the brain that responds to words about clothing, appearance, numbers and measurements. Our semantic models are good at predicting responses to language in several big swaths of the cortex. But we also get the fine-grained information that tells us what kind of information is represented in each brain area. That's why these maps are so exciting and hold so much potential. The study's senior author, Jack Galland adds, although the maps are broadly consistent across individuals, there are also substantial individual differences. We will need to conduct further studies across a larger, more diverse sample of people before we will be able to map the individual differences in detail. The ramifications of this study are many. One day, scientists may be able to track the brain activity in patients who have communication problems and match their data to language maps to determine what the patients were trying to say.